Going. Start the stream. Good afternoon, everybody. I almost said morning, right? But the clock shifted and it's now afternoon. Would have been almost morning. Do we have everybody? Let's see. Anthony's here now. Esmeralda's here now. I don't see Anai or Melissa. Okay, still missing 2 of them. All right, we'll see if they come later. Okay, so I guess it's not working. I don't have sound, so you'll have to communicate via typing it into the chat. No, just kidding. See, there it is. Epson, PJ. I do have sound. Just when you think you know how computers work, they change on you, and then it's all completely different, and suddenly it's like nothing. Quantum physics, very similar concept. You start out not knowing anything about quantum mechanics, and then you learn a little bit, and you think, okay, this isn't so bad, and then you learn how much more there is that you do not understand, and so your understanding of it plummets. And then you get to a point where you learn a lot of it, and you think you really understand it. And at that point, you have been fooled because you do not understand quantum mechanics. Anyways, let's do some math. Simple geometry, much better than quantum mechanics. I think we can handle that. All right, so before today's topic, let's roll back to, what number was it, 1.8? Last week, Wednesdays. So here are my final pictures for Wednesday's work. See how you did there. Again, yours doesn't have to be exactly perfect the same way, but you got to key in on those structures, right? Make sure this thing is entirely made out of rectangles, 3-dimensional rectangles that rendered on the 2D picture look more like parallelograms. I understand. They're there. I got one other person came in. What just happened? Haha, just kidding. Get back over there. Why did they do this to us? Okay, who just came in? Melissa? Yes? Jasmine? What? Okay, you're not Melissa. You are Melissa. Oh, well then why didn't you just say yes or nod your head or something? I'm so confused here. All right. Okay, this one, because it is 2 squares connected by rectangles, it is square-based prism. This guy, 2 pentagons connected by rectangles, pentagonal prism. Slicing the cylinder this way gives us a rectangle. Slicing the cone this way gives us a triangle, both of which you could slice the other way and end up with circles. Number 7 down there. I can see 4 by 3 by 48. There are 48 total cubes in this cube. I don't know why it keeps doing that. And I can see 12 of them on this face. Of course, you don't count those 4. So I can see 12 of them on the other side, and another 6 on the bottom row below that. Keeps cutting in and out. I don't think I can rely on this guy. No, still don't want to say there. Okay, nope. We don't even get the projector anymore. All right, go ahead and join the Zoom. That way you get the visual there. Okay, but at least that part is still working. Yes? No? Good. Unplug you so you stop trying to confuse yourself. Anyways, where were we? Number 7. This rectangular prism, right, is a 3 by 4 by 4, so there are 48 total little blocks in there. I can see 12 of them on this side, so I can see 12 here. And I've already counted these ones. Remember, this face is connected to that one, so don't count that cube again. So I get 12 more on this side. And then again, I've already counted this row and this row. So there's 6 more down here that haven't been accounted for. 12 plus 12 plus 6, I have 30 seen blocks that I can see on the front here. Which means, this is a bit of subtraction, 18 of them are hiding behind the rest. And then number 8, much simpler here. This down here is 4 long, which means the top up here is also 4 all the way out to the edge. 3 is this much, so that leaves 1 left for y. Same, the whole thing is 4 tall. This much is 2, so then the x height left over, 4 minus 2 is 2. All right, do we have any questions on this section? No? All right, then let's go to this week's stuff here. And oh, I forgot to erase it from last time. Okay, spoiler alert. Oh. This weekend you read all about angle relationships and parallel line angle relationships. And the book didn't give you the answers right away. It gave you these conjectures and tasked you with filling them in by figuring things out. Drawing on one sheet of paper. I think one of them had you draw on a second one and lay it over top. That's really great physical, visual way to figure these out. I highly recommend you do so when presented the opportunity. It will help cement it in your brain if you can work through and justify it to yourself. Oh yeah, that makes sense. I can see right now that they're the same or they're supplementary or whatever. I also had a link to a digital version that you could play around with this and explore these relationships yourself. So you should have a pretty good idea of what goes in here. But let's make sure we're all on the same page and using the same vocabulary. Okay? So a linear, no, not, well, just as I click the button. A linear pair, remember, is 2 angles that form a line. So it looks like a line with one angle sticking off of it like that. So you've got one angle out here, another angle out there. They're not necessarily the same size, okay? But there is always a special relationship between those measurements. What is it? If 2 angles form a linear pair, then they are what? Go ahead and type in chat. What do you think? As I figure out how to write. They are. How would you describe those measurements? What's the relationship there? You had something in your notes. Write it down. I don't see you typing. Come on. What is it? What's the relationship there? Give me some answers. What if I give you a word bank? How about that? I'll make it multiple choice for you. Anytime we are trying to compare angle measures it will always be one of these three terms. Okay? This is with the measures. What we're starting about here, a linear pair, is a relationship based on the configuration. These angles are configured such a way to form a linear pair. And that will mean their measures have one of the following relationships. Either they are equal, and thus the angles are congruent. They add to 90 degrees, and thus they are complementary. Or their measures add to 180 degrees, and thus supplementary. Every angle measure relationship will be one of those three words. So which one do you think describes this scenario? Jackie's got an answer. It's a good one too. Anyone else want to back her up? Or contradict? Come on, I need to see more answers here. Thank you, Anthony. There's a second one. Okay, we've got 2 votes now. 3 votes now. Very good. All right, you found your keyboards again. They are indeed supplementary. All right. That's linear pair. Okay? Anytime you see 2 angles conjoined to make a straight line there, they're going to add to 180. The term for that is supplementary. Now, how about vertical angles? What happens when I have 2 vertical angles? Remember, vertical angles are across the intersection from each other. So if I take 2 lines here, intersect like that, I've got this angle there and this angle here. So not the adjacent one, not the linear pair guy, the one catty corner from it. All right? And no matter how my lines intersect, we could have it this way, we could go this way. Look what happens with those left and right, or you could look at the top and the bottom. If one of them is larger, the other one is larger. When one of them gets small, the other one gets small. So how would you describe the relationship of those angle measures? They are what? Type it in the chat. I've got 1 vote in. Got another answer? That's a good answer, Jackie. Do we have a term for that? Can we use one of our vocabulary terms from here? Another vote for complementary. It'd be nice, right? But take a look here. I'm going to draw these two lines. Do you really think this angle plus that angle are going to combine to give me a full 90 degrees? They're much too small. So they will not always end up complementary. But if I make one bigger by tilting my line there, yeah. Notice that the other side also necessarily will get bigger, right? They always have to say the same size, so they must be congruent. Very good. And you can write the word, or we have a fancy symbol for that, equals with the squiggle on top. They must be congruent. If two angles are vertical angles, then they are congruent. Notice the formatting of that sentence. It is an if, then. It's a conditional statement. We phrase this in such a way that we could use it in the future in part of a logical argument for something. Hey, how do you know that that angle has to be 13 degrees? Well, I know that this other angle over here was 13 degrees, and they are vertical angles, and I know if they're vertical angles, then they must be congruent. Therefore, it must be 13 degrees. That's the kind of thing you're going to have to do up here. So on our practice for today, you're going to be using those two conjectures as fact. Okay? We call them conjectures because we haven't proven them yet. Right? Technically, we've only seen them based on pattern recognition. We've done inductive reasoning to determine those conjectures. We haven't deductively proven them from some other known principles yet. We'll see proofs for that stuff later down the line. But let's just say, for the sake of argument, if you trust me, if you trust the textbook, it's true. They're totally going to end up absolutely 100% true. So they're really useful, and we'll go ahead and use them now. Okay? So you can do things like that. You can look at this and say, these two angles are vertical angles. They're across the intersection from one another. Therefore, I know something about the measurements, right? These two angles, or these two, B and C, right, are along this line right here. They are a linear pair, so I know something about the angle measures. If I know the number for one, I can find the number that goes with the other. That's what you'll be tasked with doing. And you'll see that a lot on the SAT. In fact, the SAT is probably going to have this concept combined with something else, either triangles, possibly circles, or much more likely the parallel lines. There's almost always one question dealing with angles inside parallel lines. So we will play more with those exercises tomorrow. But for today, let's go ahead and get through all of the conjectures. That way we complete our notes all in one day, and then we'll have more time for exercise tomorrow. All right? So let me go through and clear some of my notes from last time. Spoilers, don't look. Okay, we're back. So corresponding angles conjecture. If two parallel lines are cut by a transversal. Okay, let's make sure we got the setup here. Here's two parallel lines. They're marked the same mark. Those are parallel. Cut by a transversal, some other line going across and intersecting them. Okay? Then the corresponding angles, they've already highlighted them for us. Here's a pair, 2 and 6. We could also look at, this angle and this angle would be a pair of corresponding. They're in the same position relative to the intersection, right? So from the intersection point, this is the upper right-hand corner. From the intersection point, this is the upper right-hand corner. Okay? So as long as they're both in the same corner, they are corresponding. And that happens no matter what. Let me just draw an alternate diagram here. If I had, not a curve, it was a nice curve too, right? If I had this, Two very not parallel lines, obviously not parallel, but they have a transversal across them. Still counts. It's one line intersecting multiple lines. This angle here and this angle here are still corresponding. Right? That's a relationship of the configuration. They are corresponding angles. But if the lines are parallel, right? If the lines are parallel, then we get something even more special. What is now true about the angle measures here? I've got one answer. Need some consensus. I'm going to start calling on people. Who have I not heard from yet? Esmeralda, I don't see a comment from you yet. What do you think? Which of those three terms would you use to describe the measures of angles 2 and 6 here? Anthony, corresponding is, that's already established. You can't use the same word in its own definition. Different word. One of the angle measure ones. Corresponding describes the positions. How would we describe now the measurements?
Congruent.
Are they congruent, supplementary, or complementary?
They're
Congruent. Final answer. You are correct, sir. The corresponding angles are congruent if the lines were parallel, right? You saw from my other diagram they were clearly not. Okay? We can't always rely on what something looks like to say what it is, but we can definitely see when it's not. Okay? So if they're parallel, then those corresponding angles are congruent. All right, another setup. If two parallel lines are cut by a transversal, then alternate interior angles, this is a fun one, this is the Z angles. See that Z in there? Right? Alternate interior. So both angles are between the parallel lines, they're on the inside, and they're on alternate sides. You can see one is on the left side, one is on the right-hand side. They're on alternate sides of the transversal. Alternate interior angles. Again, that configuration shows up whether or not they're parallel or not. But if the lines are parallel, then the measures of the corresponding angles lead them to be what? Anthony says congruent again. Does anybody agree with him? Congruent, that was the answer for the last one. Again? Really? No one's going to back him up on that? You should. Anthony knows what he's talking about. They are congruent again. Absolutely. What are you nodding your head for? Why didn't you type it in then? All right. Yes, alternate interior angles will be congruent. And one more, alternate exterior angles. Okay, look at where those are now. Here's the parallel lines. Our angles are outside, on the outside of the parallel lines, right? And we still have left and right on opposite sides of the transversal, so that's where we get the alternate from. Alternate exterior angles. those measurements are once again equal. I'll just give that one to you. If the lines are parallel, then even the alternate exterior angles will be congruent. All right? All three sets end up congruent. Right? It's so very convenient that, in fact, our book said, you know what? We don't need to make those separate statements. Let's combine all that into one conjecture, the parallel lines conjecture. Right? See how we got C3 here instead of parts A, B, and C? So here we go. If two parallel lines are cut by a transversal, then we can conclude all of the following. The corresponding angles are congruent. The alternate interior angles are congruent. The alternate exterior angles are congruent. In fact, this is such a specific trait of parallel lines that in this case, the converse will also be true. Remember from last quarter, the converse is when I take my conditional and I reverse it, go backwards. It's not always true, logically, automatically. But in this circumstance, it does happen to be true. I can reverse it. So not only can I conclude, if they're parallel, then these are congruent. But if I'm given a diagram, I don't know that they're parallel. But if I know these pairs are congruent, then I can conclude, the lines must be parallel. It works both ways. If two lines are cut by a transversal and they form congruent corresponding angles, or congruent alternate interior angles, or congruent alternate exterior angles, if I'm given any of those combinations, the lines are parallel. You can use your symbol or you can write out the full word there. That's really handy. The SAT loves to give you a diagram and it won't tell you whether or not the lines are parallel. You'll have to figure that out. You're like, wait, are they? And you have to check. It's a test. Can we tell if these are parallel or not? We'll do some practice of that tomorrow. All right. Drew a little picture to go with that. All right. Look at these lines here. They don't look quite parallel. I did a pretty sloppy job drawing them up. But I said this angle is 37 and this angle is 37. Those are alternate interior angles. And they are congruent. Therefore, I can conclude the lines must be parallel, even if they don't look that way. Right? Okay, any questions on these conjectures?
No.
No? Okay, then you have the rest of the period to work on questions 1 through 15 from the 2.5 practice. Mainly dealing with just those first two conjectures about the angle relationships. Tomorrow we will throw the parallel lines in there as well. I think it's real fun. This is like figuring out a Sudoku, right? It gives you a limited bit of information. You have to try to fill in all the rest of it. Maybe that's what we can do on Friday. Do Sudoku puzzles. All right, no questions. So I'm going to stop the stream here.